Hi everyone, welcome to a Tess Academy YouTube video. This is part of our GCSE Physics revision lesson series. Today we'll run through the atomic model. Remember, if you have any queries, please visit our website at tessonlineschool.com. Also, please suggest any feedback, improvements or suggestions to us through the website. Thank you. Learning how the atomic model evolved over time is immensely important, not only just to know the scientific history, but also because you are often tested about the history of the atomic model through a variety of questions ranging from multiple choice questions to 6-marker describe questions. The atomic model has clearly changed throughout history. The ancient Greeks believed all matter was made from invisible particles that were not yet classified, but later models described atoms as solid spheres like the diagram and that different types of spheres made up each element. The latter part has been found to be correct. However, as scientists made more discoveries, old models were replaced and newer ones began to emerge with modifications and refinements due to support from experimental evidence. The first important pioneer in the atomic model progression that we need to be aware of is J.J. Thomson. J.J. Thomson discovered the existence of electrons at the end of the 19th century. This new evidence helped to develop a better model of the atom that was more detailed as it included subatomic particles. The new proposed model was called the PLUM pudding model. This is because the PLUM pudding model consists of a positively charged sphere, which is the pudding, with negative electrons, which are the plums embedded in it. This model made sense because it was known that the electrons were smaller than atoms. The overall charge of this model is neutral, as the negative charge from the electrons cancels the positive charge from the sphere. So as you can see in the diagram, we have the positive sphere in the purple and the negative electrons embedded randomly all over, just like a plum pudding. Following Thomson, there was Rutherford. In 1909, Ernest Rutherford, along with two of his students, were investigating the plum pudding model and its validity. They fired alpha particles, He2 plus ions, at a very thin gold foil. They expected most alpha particles to be deflected very slightly due to the positive pudding, as the positive ions would be deflected by the positive sphere. However, they discovered that most alpha particles passed straight through the gold atoms, as shown by alpha beam 1 in the diagram. Some changed direction but continued through the foil, as shown by alpha beam 2 in the diagram, and a few bounced back off the gold foil, as shown by the last alpha beam 3 in the diagram. Using these observations, Rutherford came to a few important conclusions. Now, please learn these because these are often tested in exams. Most alpha particles pass straight through the gold atoms, which show that the atoms are mostly empty space that couldn't stop the alpha particles passing through. Some changed direction but continued through the foil shows that an atom's nucleus has a strong positive charge that deflects and pushes away the positive alpha ions. And a few bounced back off the gold foil shows that the atoms have a very small and heavy nucleus that completely repels the positive ions. Therefore, Rutherford concluded that actually the atoms look a little bit different and created a new and improved model called the nuclear model. The nuclear model consists of a tiny positively charged nucleus at the center of the atom, where most of the atom's mass is concentrated in. The nucleus is surrounded and orbited by a cloud of negative electrons at a distance, as shown in the diagram, and that most of the atom is empty space. This new model then replaced the plum pudding model. Only 4 years later, in 1913, Niels Bohr proposed a newer and improved model of the atom. In Bohr's model, electrons orbit the nucleus at different and fixed, which means unchanged, distances. The different orbit distances are called energy shells, and each energy shell can hold a certain number of electrons. So for example, in the diagrams, you can see the first energy level can only hold 2 electrons, and the second and third energy level hold 8 electrons, which you need to know. Also, in the other diagram, you can see that the nucleus is at the very center, with electrons orbiting in fixed shells as they cannot move from one place to another, and they're not randomly placed about. How was Bohr's model any more beneficial? Well, Bohr's model was better as it was able to explain emission and absorption of EM radiation. We will learn about this in the following videos. It was able to explain findings from other experiments better than the previously proposed models, and the theoretical calculations of Bohr agreed with experimental observations. We have discussed the electron, but now let's talk about the proton discovery. Ernest Rutherford investigated the nucleus and found out that the nucleus could be broken down into smaller positively charged particles. Each of these particles had the same amount of positive charge. He called these positively charged particles protons. He also found out that a proton has the same charge as a hydrogen nucleus, just like the alpha particles he previously investigated with. Following on after the proton, there was the neutron discovery. This occurred because the nuclear model had a few problems. The nucleus of the atom was heavier than it would be if it just only contained protons. This suggested the existence of another subatomic particle with mass but no charge. Scientists struggled to prove this with experimental evidence. James Chadwick provided the evidence to show the existence of another subatomic particle within the nucleus and called them neutrons. Now, let's test our understanding of the atomic model and answer a few exam questions. Firstly, who created the nuclear model? Answer this independently on a piece of paper after pausing the video and return once you have your answer to mark it. The answer is Rutherford. He created the nuclear model after his experiments with the alpha particles and the thin gold foil. Next question. Describe 3 differences between the plum pudding model and the nuclear model. Firstly, remember that in the exam you do need to be able to compare all the different types of models you learn about. Additionally, just because of the wording of the question and as you are listing differences, you need to use comparative language, for example, whereas, or however, or on the other hand, to make your differences very distinct and easy for the examiners to mark. In total, this question is worth 6 marks and you need to make sure to use comparative language and use points that link with each other to attain the 2 marks for each bullet point. The first thing you could have said is that within the plum pudding model, an atom is mostly a positive charged sphere or a plum, whereas in the nuclear model, the atom is mostly empty space. Another point you could have mentioned is that in the plum pudding model, electrons are distributed throughout the atom randomly. However, in the nuclear model, electrons orbit the nucleus at a distance. Lastly, you could have said that in the plum pudding model, the mass of the atom is evenly distributed, whereas on the other hand, in the nuclear model, the mass of the atom is concentrated in the nucleus. Thank you for watching. Remember, if you would like further support, we offer one-to-one sessions and group sessions for Key Stages 1, 2 and 3, along with specially formulated 11+, GCSE and A-level lessons. Further information can be accessed on our website at tessonlineschool.com. And if you would like further resources, advice and feedback, please contact us on the following numbers. Thank you.